Hello, this is Dead Hamster, and today we're going to attempt part 5, where we finish up the tutorial here, and we export the course geometry and load it into a Mario Kart 64 game. So to start, we are going to, we've followed all the other steps. We have our course paths, our objects, all of our course objects and surface objects and section views, and everything is properly listed under the parent nodes and has a unique names based on the material or the surface ID. We follow the tutorial, everything is set up properly. Last thing we're going to do before exporting, unhide everything so that the entire scene is visible, or alternatively, select everything in the scene via the navigation tool here on the side. And we're going to take the material that we have for all our objects, where we list all the submaterials here, and we're going to assign to the selection. Alternatively, you can drag it onto the object and hit assign to selection. What's important is that every object in the scene is using the same materials, or rather at least is using a material that is supposed to be in the game. When the Overcart program loads the FBX file, it's going to parse every material in the scene, it's going to read all the textures from those materials, and it's going to write all of them into the Mario Kart ROM. So if you have a material that doesn't have a texture, or if there is a extra material that has a badly formatted texture that you weren't planning on using, it needs to be replaced before you export the data, or else again the program won't be able to properly parse through the FBX file and load the course. So we're going to export. I'm just going to delete these first. I'll call it course data.fbx. There's a few things that are important here. We do not want to embed the media. We do not want any lights, cameras, or animations. For geometry, we don't need smoothing groups, normals, tangents, turbo smooth, selection sets, bones, or instances. We just want to triangulate and preserve edge orientation. Down below, the up axis should be Y up. The type is the ASCII, the text format, and the specific version is 2013. If you are unable to export into either the text format or 2013, there is a free converter from Autodesk that will convert between any format and any version so that you can properly get it into this file. I know that Blender only exports the binary version for 2.7. I'm not certain yet about 2.8. Regardless, Overcart requires the ASCII 2013 format for the FBX file. With that set, go ahead and export. If you get a crash here, you probably ran out of memory. There are a lot of objects, especially with complicated courses, and when exporting, 3DS eats up a lot of extra RAM. Once, however, you have gotten that file, we're going to open the geometry compiler. We want to load our course data.fbx file. It'll take a second or two before it gives you the dialog message. So from here, we can view on the first tab all the section views that we created earlier. We had all 6 of our sections, as well as the 4 views, north, east, south, and west. This is a list of all of the course objects, and the checkboxes represent which ones are drawn based on the current section view. You can modify this. I could go in and add or remove parts from section views using only this editor, if you so chose, and you could see the updated stats here. There is no way to export this back out, so these modifications are only for quick edits before you compile the ROM, if you know that there was something wrong with the setup beforehand. Same thing with the surface map tab. We have some options. It gives you the total section count. It'll tell you what section the object you've selected belongs to, as well as what the surface material is. And again, these can be modified to change the data before compiling to the ROM. The third tab is the texture data. It'll show you all the materials from 0 to the last and display the current bitmap as well as the formatting that it's going to be applied to in the ROM. Currently everything is going to be RGBA 16, and it can be either 32 by 32, 64 by 32, or 32 by 64. There is no other size option available. You cannot do 16 by 64, that's not okay. You cannot do 16 by 128, that is not okay. You cannot do 64 by 64, that is not okay. You can only do 32 by 32, 32 by 64, and 64 by 32 pixel images. That is a limitation on how Mario Kart 64 compresses its course data. If you wanted to write a custom F3D object and store it separately, you can, but the course data that is stored in segment 7 and the compression format applied to it only allows for a total of 6 texture classes. It's the 3 sizes and the 2 formats, RGBA 16 and CI8, which are the 2 different formats available for textures. The last tab will be the Course Info tab. Here we're going to select a ROM image. We need a Mario Kart 64 ROM that has had the hot swap patch applied to it. You'll see that included in the download with all the other tools. The hot swap patch allows for the loading of custom courses. Without the hot swap patch, you will not be able to load your custom course. So I know that I have this. For the pop file, this is the course paths that we exported earlier. This is the course paths and objects. The preview image, banner image, map image, and ASM routines can all be left empty. If you have properly formatted data that you know will be properly set for the future, you can write that to the ROM. There is nothing yet in the hot swap patch to load it, but it is currently all aligned properly and the data is available to write, and I know where it's going to be stored later. So if you have the properly sized data, the properly sized images rather, and you want to put them into the ROM, you can do so. But currently, again, I don't have a method for loading it back out and applying it in game yet. It's just going to be written into the ROM. If the hot swap patch is updated in the future to include that, it will be. When it's updated in the future, the idea is that all of these items that have been written to it already will be grandfathered in, and we'll be able to load that data and apply it in. So if you have it and you know what to do with it, you can put it in now. Otherwise, you can leave it blank and it won't affect anything. The output directory, we do need to set. This is where it's going to write all of the files. We're going to put that here. The course name is only used internally, so we're just going to do something like that. The sky color, again, will be written to the ROM, but it's currently not loaded. Same thing with the map coordinates. It will be written to the ROM, but they are currently not loaded. There are up to 64 courses that are available for custom levels. There are 4 sets, the 4 traditional cups, and then each cup, of course, has 4 courses. So on this ROM, I've already replaced Luigi's Raceway with Peach's Castle. So keeping in set A in the Mushroom Cup, in course 2, we'll put in Lon Lon Ranch. Now, when we go to hit compile, we're going to get an error. It says right here, UV out of range for object 8 part 0. The UV coordinates for Mario Kart 64, they're limited as int16, they're 16-bit integers. Because of that, excessively long triangles with excessively high tiled textures will overflow and cause an error. So this is going to catch that before it happens, give you an error message, and then it's going to crash. Okay, so we're going to go ahead and fix that UV error that popped up. Again, it said object error 8 part 0 had a UV that was out of range. So if we look at that object back in the 3D editor, we can see a very long triangle on the object, as well as a very heavily tiled UV map. And we can say the same for, on the opposite end, in the same object, we have a similar scenario with a very highly tiled triangle. So what we're going to do is just divide these two triangles in half. The easiest way is to turn them into polygons, editable polys rather. Doing a slice. And then doing the same here. Then I would take these verts, and should be able to grab both of those. Hopefully the preserve UVs will cooperate with us. We can drop that. And look at that. It actually worked pretty well. I'm going to convert it back to a mesh and weld all the verts that are 0.1 apart. That's just going to get rid of all the extras. When you go from poly to mesh, it duplicates a lot of verts, it seems, and we don't want those to get written to the file by mistake. So we should end up now, looks like it was actually negative 56, not 57. There we go. We'll put those two together. So we'll put those two together. Okay, we'll play hardball. I'm just going to take a moment just to line these up. Okay. And same thing over here, I would imagine. Yep, we want to pull that up. Right, negative 57. I know why. It's because I did this without the preserved UV from editable poly, but that's okay. Move that vert down and just tweak the UV map of this ever so slightly. We go into unwrap UVs. And we're just looking for this one vert actually. Here we go. Yeah, look at that. There we go. There we go. No, I didn't quite get it. Let's go back in. Undo, undo, undo. Open this back up. So you can see the little bit there. And we should actually be able to just have to know which material it is. All right. Hold yes, I don't know what that means, but sure. 8, okay, back. There we go. So take this one little dot, put it right there. Okay, so we've edited the object, we subdivided it. Hopefully now the UVs will be in range. Because we're dealing with a smaller triangle, there's not as large of a stretch across the object. So we're going to re-export our FBX file. Before we do, let's save, and then we'll export it. Let it write everything, wait for it to finish. And now we can load it up again. Perfect. So again, same thing as before, surface map, texture data. We're going to set it to course 2. Select the original ROM that has had the hot swap patch applied to it. Select your pop file. Select the output directory and give the course a name. From here, we'll go ahead and try compile again. This is a warning, but if it doesn't crash, it's okay. It's just a warning. This is again about the vert cache error. It won't be able to compile if it runs past that 32 vert limit. So it'll crash, you'll know that something was wrong, and you'll know it was object 8 part 0. So this, however, again, we'll have to edit. This is 255 part 6. So up here under, this is actually a surface object, I know just because it's 255 part 6. What do you know? The exact same object, just now the surface version. So what we're going to do for the surface object is we're going to cheat, because the surface objects are invisible. You never see them. They're never in the game. So we're just going to do that. And it looks awful, but that's what we're going to do. And now we'll export this again. Wait for it to go through. And I don't want to do that to the entire surface table, because again, it's nice being able to look at it in the 3D editor. It does look terrible. But that is a very quick way, if you don't want to go through manually like this and find each object out of range, to be able to do the whole thing at once. No, I don't use that one. Okay, so load up the FBX file. That's my controller. That's not the, yeah, you can see that. Pop file is right next to it. Output directory is easy. Name it, change it to course 2. And it's loaded. All right, let's give it another run. Damn. Part 7. Oh, there we are. Oh, true. There we go. All right, where's part 7? Why is that a problem? All right, you know what? Like I said before, nice easy fix. It's not pretty, but for the surface table, I do not want to deal with UV errors. So we're just gonna do one of those, and that should just about cover the whole thing. Just in case, let's do that. Somewhere between. Got it right the first time. Leave it there. All right, let's try again. Wonderful. Once that's done, again, go through and try to load up the geometry compiler. I don't know what I just clicked, but I don't think it was an FBX file. If it was, it sure didn't like to... Oh, that's why. Okay, that makes sense. Pay attention when you're clicking on things. Okay, so again, we're going to load the pop file, put that here. Output directory. The ROM, and set to course 2. Alright, so from here, hit compile. And that's it. This might actually work. So we're going to go ahead and give that a test run. Looking in our output folder, we'll find a new ROM called Mario Kart 64, as well as all the segments that were written to the ROM, all the segment data that you can use for debugging if your course is to crash, which we might. Let's find out. Let's see what happens. First, let's turn off the plugin we used before for exporting. Just go to the standard video plugin. So we're going to go to set A by hitting the R button one time, which will put us in set A. And we'll see what happens. Oh, that's not good. That's not good at all. So definitely crashed. I'll have to look into why that is. All right, so I do want to just rule out one thing just to be sure. So we're going to Oh, and actually, I don't even want to use this one. So do another quick test. What I did is actually the process of applying the patch. I don't know, I've never tried to load a second course, this is the first time. So I'm not sure if I may have some more kinks to work out. We'll find out in a moment, I suppose. So set A, definitely something wrong with the course. So need to look at the segment data perhaps, see what's wrong with that. But that is the process for compiling a course for Mario Kart 64. The debugging process is a whole nother beast entirely, and that's something you really have to have a pretty good understanding of what's going on for. Unfortunately, a lot of things still in beta, still in infancy, and you need to kind of know what's going on in order to be able to do this kind of stuff. Definitely not for beginners. But this will at least outline the process and let people know, the steps you need to take in order to get things going. So I'll post a part 6 debugging in the future when I figured out what went wrong here. But until then, until next time.